everyone. Welcome to the session on Introduction to Computational Problem Solving. So in this session, we'll be talking about that what is a computational problem and how can we solve it in computer science. So let's try to recall the fundamental stuff which we have talked about in the course about major components of a computer. So computer is primarily composed of two major components. One is the hardware. The other one is software. Hardware is composed of the physical components like RAM, hard disk, central processing unit, monitor, keyboard, and all those things which have physical existence to make up the computer. In addition to that, what we have studied so far is that hardware is dumb, which means that it has no intelligence. So hardware cannot do anything on its own. So whatever it does, we have to provide it with the proper sequence of instructions. So the second component which we have discovered so far in our discussions is software. So the software is primarily composed of things which don't have the physical existence. So those are non-physical components, but they're critical to make the hardware functional or useful for our requirements. So for example, we talked about operating systems like Windows, macOS, Android, etc. So if these operating systems or any one of them is not installed on our computing devices, we won't be able to use the computers in a proper way. The software essentially enables the hardware to work for us in a useful manner. So besides the operating system, there is a category of software which is called application software. So application software is primarily used to solve certain problems of a particular nature. So for example, we have been using different application software in our daily life, like we use Microsoft Word, we use internet browsers, we use media player to play different audios and videos. We might be playing different games on computers. So all these softwares are pre-built application software. So they essentially are of applied nature. They address a particular problem. For example, Microsoft Word is used to write documents. Microsoft PowerPoint is used to create presentations. Excel is usually used to do some mathematical or statistical stuff. And similarly, browser is used to explore different websites. Uh, so the kind of critical thing where we are trying to land into is that we are interested in figuring out that how to develop an application software. So in this course, we'll be using this term program. So program and application software are essentially interchangeable terms. So when we use the term program, that like involves, we usually get involved more into the development stuff of that application software. So by development, we mean that how to create an application software or how to solve a particular application problem such that we can use it on computers. So let's try to characterize the computational problem. So the first thing is that whenever we are posed a computational problem, we need to understand it. We need to understand the problem. We more specifically we want to understand the what part of the problem, that what is the problem. So when you say what is the problem, so there are two critical ingredients within that thing we need to understand. One is that we need to identify the input. By input we mean that what has been provided to us, what kind of data or what kind of situations will be provided to us to address that particular problem. So that is part one of characterization of a computation problem, that we need to identify the given input. The second component over here is to identify the desired output, that what has been given, by desired output, we mean that what do we need to produce as part of that whole solution. So we have been given an input, so what do we need to produce out of that input? So once we succeed to figure out that what is the given input and what is the desired output, that primarily completes the what part of the problem, then what is the problem, what is nature of the problem. So we have partially characterized the problem from the what perspective, that we understand the problem at least. We have not talked about the solution so far. So a simple like real world example of characterizing a problem could be that if I ask you to figure out that, for example, your task is to make tea, So the first thing, part one of understanding the problem is that you need to figure out that in order to make tea, what would be the kind of ingredients provided to you. So you need to figure out, like for example, you might have been given water, you might be given sugar, you might be given tea itself, you might be given some milk. So all those things which are used to make tea are primarily input to that whole problem. So our problem is making tea. So we need to first understand the ingredients of that particular problem. That what do we need to have at hand in order to solve that problem. The second major component of understanding the problem is that we need to understand the output, that by using those ingredients, what kind of thing we need to create, what kind of thing we need to produce as the output. So if we are unable to figure out that what is tea or what do we need to make out of those ingredients, that essentially means that we have not really understood the problem. So that's what that's sorry. That's what makes it the what part of the problem. The second is that how to solve it. So when we say how to solve it, that essentially means that we need to think of ideas to convert the given input to the desired output. So for example, if you think of the tea example, so we need to figure out that we have been given some ingredients and our ultimate goal is to make tea. So what would be those ideas which will help us to convert that collection of ingredients into the desired product? So that means that we need to come up with a recipe. We need to have a recipe at hand, or we need to create a recipe. By recipe, we mean that we need to have sequence of steps to generate the desired product from the given input. So if you know the recipe beforehand, that's good. If you don't know the recipe, then your fundamental task over here in the green part is that you need to create that recipe. And that is a completely intellectual exercise that you need to figure out ideas, you need to brainstorm ideas, and you need to convert your ideas into a sequence of steps such that you can make up a sensible recipe, which can lead you to the success. And over here, by successful mean that we have been able to generate the desired output from the given input. So the recipe, then once we have the recipe, we have a clear thought about the recipe or about the sequence of steps. Then the next step is that how we need to formally write the recipe. So recipe can be written in different ways. There are two major ways. The first way in computer science is known as that we need to write that sequence of steps to solve the problem as an algorithm. So algorithm is essentially the solution. And sometimes we call it that we are using pseudocode to write algorithm. So algorithm is essentially a non-executable solution. By non-executable solution, we mean that we don't aim to run or execute the solution on the computer directly. It is not dependent on a particular language. It is a language free uh, method of writing or chalking out that whole solution or recipe. So you can write your algorithm in any language. You might be using a mix of English and mathematical symbols, or you might be using some other language of your choice, and you can come up with a clear, unambiguous idea of the solution. So the second, so once we have that solution idea, the next thing is that how to get it done on computers. So for that purpose, what we do is that we use this term called program. So program is essentially the solution written in a particular programming language, and that is an executable solution. So by executable solution, we mean that this solution can be executed or should possibly be executed on computers. And when we say we are executing it on computers, that means that it can solve the problem on computers. But who is going to write down the program? It is you. It is the programmer, right? And programmer would have like walked through all those previous three steps that the programmer identified the problem, they characterized the problem, identified the given input and desired output, and then they chalked out that how to convert that input into the given output. All right, so before moving forward, we must be having a very clear idea that what do we mean by an algorithm, by a program, and how we have come through this whole exercise of designing a program. So a program is developed using a complete life cycle. So the first step is that we have a computational problem at hand. our first step or first task is to understand the problem, chalk out the solution idea. So once we've chalked out the solution idea, that means that we have an algorithm in our mind. We might have written that algorithm on our notebook or on a piece of paper, and we have converted that algorithm into a program of particular programming language. Then what we do is that the next step is that we start writing the program. So we use an editor usually. Editor is a software which is used to write or design the program. And for that particular problem, we need to have we should have already selected a particular programming language so that we can use an appropriate editor. And using the rules of that language, we'll be writing the program. So the third step is that that program which we would have written in a particular programming language, we need to compile it into the binary language. So binary language is essentially the language of machines, language of the computers. So everything needs to be translated in the form of zeros and ones. And for that purpose, we need to use the appropriate compiler of that language which we have chosen to write the program in. Once we have successfully compiled the program, the next step is to execute the compiled program on the computer. So execution or running the program are interchangeable terms. So we might be executing or running the program if it has been successfully compiled. And during that whole execution process, we need to test it if it solves the given computation problem. By testing, we mean that we have to just verify that it is generating the desired output. So we might be testing it on different sample inputs, and we need to figure out that is it really generating the desired output. If yes, then that's a successful program. If not, then we need to go back. We need to look at the edited program, the written program, and we might have to make some modifications if it is not correctly generating the desired output. So what we have come across so far is that we know what is a program. So program is essentially a sequence of steps written in a particular programming language. In order to write a program, we need to choose a particular programming language. By choosing a programming language means that we need to learn a programming language. So we have actually a lot of options in market, which are like hot programming languages available these days. So for example, Scratch, C++, Java, Python, etc. So in this course, what we're going to do is that we're going to start with Scratch. So Scratch is a very simple programming language which has a clear, easy, and very attractive attribute of visualization. So all those pieces of code which we design over here are primarily available to us in a visual environment. And this language was developed in MIT a few years back. So we'll be using Scratch, and for that purpose, you'll be learning onto this online available editor, scratch.mit.edu. Or the other alternate choice is that if you want to do some stuff offline, so you can like freely download its desktop version and download Scratch and start playing with it. So in the next video, you'll be seeing that how to like start with Scratch. Thank you.